viewers. In today's class we are going to solve some important trigonometric limits. So here we are going to evaluate some important limits involving trigonometric functions. So before solving the limits, let me write one important limit, that is limit x tends to 0, sin x over x is always equal to 1. So this is an important limit which will be used in evaluating the trigonometric limits. So let us take the first one. So suppose we have to evaluate the limit x tends to 0, 1 minus cos x divided by x, right? So viewers, here we'll make use of some trigonometric results. So we know that 1 minus cos x is equal to 2 sine square x by 2. So this result shall be used in evaluating this limit. So let L be the limit, right? So L is equal to limit x tends to 0, and for 1 minus cos x we can substitute 2 sine square x by 2. So here we substitute 2 sine square x by 2 divided by x. Now this expression can now be written as limit x tends to 0, and taking this 2 to the denominator of x, so we can write it as 2 sine square x by 2 divided by x by 2, right? Now this can further be written in the form sine x by 2 divided by x by 2 times sine x by 2. So we have written sine square x by 2 two times, right? Because if we write this sine square x by 2 in this form, then we see that this expression is identical to this one, sine x over x. Now this can be written as the limit x tends to 0, and we have sine x by 2 divided by x by 2 multiplied limit x tends to 0 sine x by 2. So here we have used the result that if limit x tends to a and we have the product of two functions, then it can be written as limit x tends to a times f of x times limit x tends to a g of x, right? So this is the product of two functions. So now we see that if we apply this rule, limit x tends to 0 sine x over x equal to 1 here, then we see that this limit is equal to 1, right? Multiplied limit x tends to 0 sine x by 2. Now we know that as x approaches to 0, then limit x tends to 0 of sine x is equal to 0, right? So this limit is now equal to 0. So we have 1 times 0, that is 0. So therefore the value of this limit is equal to 0. Now let us take one more important limit. So here we have to evaluate limit x tends to 0 cos 2x minus 1 divided by cos x minus 1. So here again we'll make use of some trigonometric results, and we know that cos 2x can be written as 1 minus 2 sine square x, right? And for this cos 2x we can substitute this value, and for cos x we can write 1 minus 2 sine square x by 2, right? So let us substitute the values. So let us call this limit as L. So therefore L is equal to limit x tends to 0. For cos 2x we have 1 minus 2 sine square x, then we have minus 1, and divided by cos x minus 1. So for cos x we can write 1 minus 2 sine square x by 2 minus 1. So this one and this one get cancelled. So similarly 1 and minus 1 get cancelled. So we have limit x tends to 0 minus 2 sine square x divided by minus 2 sine square x by 2, right? Now minus 2 and minus 2 get cancelled. So we have limit x tends to 0 and sine square x divided by sine square x by 2, right? Okay, so now we can further write it as sine square x can be written as sine square x divided by x square times x square. So it means we have to express this sine square x in terms of sine x over x. So we multiply and divide it by x square, right? Similarly sine square x by 2 can be written as sine square x by 2, and here we can write x by 2 square times x by 2 square, right? Okay, so now we have limit x tends to 0, and now see this term can be written as sine x over x whole square, and here we have this x square, and in the denominator we have we can write this term as sine x by 2 divided by x by 2 whole square, and multiplied x square over 4, right? X square over 4. Now this x square and this x square get cancelled, so we have limit x tends to 0, and taking this 4 to the numerator, so we have 4 times sine x over x whole square divided by sine x by 2 divided by x by 2 square, right? Okay, now we can write this expression as taking 4 outside this limit sign. So we have limit x tends to 0, we have sine x over x whole square, and then divided by limit x tends to 0 and sine x by 2 divided by x by 2 whole square, right? So now see, here we have limit x tends to 0, sine x over x is 1, so this limit becomes 4 times 1 square, right? And divided by this limit also become 1, so this is 1 square, clear? So here we have used one important result, that is limit x tends to a of f of x divided by g of x can be written as limit x tends to a f of x divided by limit x tends to a g of x. It means the limit distributes over this function as well as this function. So here we have 4 times 1 divided by 1, that is 4. So the value of this limit is equal to 4. Now let us consider one more limit. So here we have to evaluate limit x tends to 0 tan x divided by x. So let us call this limit as L, right? Now this L can be written as limit x tends to 0, and for tan x we can write sin x divided by cos x and divided by x, right? So tan x is replaced by sin x divided by cos x. So now this can be written as limit x tends to 0 sin x divided by x times cos x, right? Now this can further be written as limit x tends to 0. Now we can take this sin x over x as one term, right? So here we have sin x over x times 1 over cos x. Now this can be written as limit x tends to 0 sin x divided by x times limit x tends to 0 1 over cos x. Now see, by making use of this result, this limit is equal to 1. So here we have 1 multiplied 1 over limit x tends to 0 cos x. Now viewers, limit x tends to 0. When x approaches to 0, then the limit cos x is always equal to 1, and when x tends to 0, limit x tends to 0 sin x is 0. So here we'll utilize this result. So we have 1 times 1 over 1, that is equal to 1. So the value of this limit is equal to 1. Now viewers, here we have seen that limit x tends to 0 sin x over x is equal to 1. So we can take this limit as a standard result as limit x tends to 0 tan x over x is always equal to 1. Now let us take this limit. So here we have to evaluate limit x tends to 0 sin 3x divided by sin 6x. So now let us call this limit as L. Now L can be written as limit x tends to 0, and now see, in the numerator we have sin 3x and in the denominator we have sin 6x. Now our aim is to express this expression in the form of sin x over x. So what we will do, we'll write sin 3x as sin 3x divided by 3x multiplied 3x, right? Similarly, sin 6x can be written as sin 6x divided by 6x times 6x. So now this term is of this form, sin x over x, and sin 6x is expressed like this. So sin 6x over 6x, right? So this is also of the form sin x over x. Now here x and x get cancelled, so we have 3 ones are 3, 3 twos are 6. Now this can be written as the limit x tends to 0 sine 3x divided by 3x divided by limit x tends to 0 as sine 6x over 6x, and here we have the factor 1 over 2, right? Now this limit is 1 and this limit is also 1 due to this result, limit x tends to 0 sine x over x equal to 1, and here we have the factor 1 over 2, so this is 1 over 2, right? So the value of this limit is equal to 1 over 2.